first, let's start with Dr. Philip. He's a researcher at TU Vienna. His focuses include trust in automation, attentive user interfaces, transparency of driving algorithms, as well as UX and acceptance of automated vehicles. And his topic is need-based UX research for automated driving. So let's start, and I will give the control to Dr. Phil.
Perfect. Yeah, thank you so much also for the invite again. Actually, I was planning to go to Aachen myself, but there is some family business that keeps me at home, so I'm very glad that there is also the option to present remotely. So I talk today about user experience research in automated driving, and I must add that a lot of that research was led by my former colleague, Anna-Katrina Frieson. Unfortunately, she's no more part of academia. She went to industry, but I thought that should not be the reason that we forget her really cool research in that area. So I presented two studies. One is also part of this year's Ivy conference as a poster, and another one is a little bit older, but I think it's still very interesting. But I begin with a couple of theoretical considerations regarding user experience, because we talk a lot about what that could mean, and yeah, let's dig into it, right? So we all know the classical levels of automation that we've seen in the driving domain, but they are also based on other levels of automation. So this is one reference to a very prominent list by Parasuraman, Sheridan, and Wickens from the 2000s. They defined these 10 levels of automation actually. From some system would offer no assistance at all, and the human must take all the decisions and actions, up to level 10, where the computer would basically decide everything and would act autonomously, completely ignoring the human. And sometimes we tend to say that we just need the proper technology, and when this technology is sophisticated enough, we can just climb up the ladder of automation. But we have to be a bit careful, because automating stuff is not always only beneficial. So automation can be both an enhancement or it can be an amputation, so to say. So actually, we want to use automation to enhance our capabilities, to make whatever we do more fun or increase our performance. But at the same time, automation could also take away things that we actually like. And we will see that later, that car driving is one of the activities that many people actually like a lot. So when we want to introduce automation in a way that it's accepted by people, we need to consider how we can still satisfy their user experiences and not amputate the things that they really like to do. So much for the start. And so Katrina did a lot of research on a field that we may call interaction design. And interaction design means to allocate functions to either humans or technology. And this would involve the full sequence of touch points between people and technology over space and time. And this is not about efficiency, it's about user experience as a whole. So what is user experience? It is defined in the ISO standard 9241-210. Basically, what you will read there is that anything that has to do with some product interactions belongs to the user experience, but that's not everything. It would also include already anticipated use, so you just imagining to use a product, and it will also, of course, use the reflection of what you would think about a product experience after it happens. So you don't even need to interact with the technology, that this already would influence your user experiences. So actually, this sounds quite a lot, right? So we need to formalize what user experience mean and how we can research it in a proper context. So one thing that we could do is we can structure it to different components. So there is, for example, a component of pragmatic quality of user experience, and that would relate to what we classically often refer to as usability. So this would mean the effectiveness or efficiency and how we can interact with a particular product. That is the pragmatic quality. But then there are also these hedonic qualities that we can either satisfy or not, depending on the product. So first, there's the component of the hedonic quality of stimulation. So this is, for example, satisfied when we feel that we have something really novel. We can see novel experiences that are satisfying for us. And then there is also the hedonic quality of identification. And that asks if the values of the product would also reflect the values of the user. So for example, me, if I'm a very environmentalist person, then a Porsche that would need a lot of gas might not necessarily product that I would identify with compared to maybe a much more environmentally friendly vehicle. So we can assess these dimensions to find out how people perceive products, and there are different scales available. So we might know scales like the system usability scale or the user experience questionnaire, but we want to even dig a dip deeper, and we looked at the relation of user experience to emotions and psychological needs. So Mark Hassensell says that UX is also a momentary, primarily evaluative feeling while interacting with the product or service. And by that, the UX shifts away from the product and the materials to the humans and the feeling, the subjective side of product experiences. So he said that there are different basic needs that need to be satisfied for a good user experience, such as autonomy, competence, stimulation, relatedness, popularity, meaning, and security. And if these needs are satisfied for a user or not, that can be assessed systematically. So for example, there is something is called the need scale. That's a questionnaire that can be used to assess the satisfaction of those needs. And there is also a qualitative assessment technique. It's called the UX cards. These are just little cards where the name of the need is stated and also what it means for a user. And you would just give study participants these cards and ask them to look at them, to read what's on these cards, and to reflect for the particular experience if they think that need was satisfied by the product or not. And in the two studies that I will just show you, we did both of these methods. So once we used the need scale and once we used the UX cards. Here you can see the example questionnaires from these need scales. So that's the more quantitative questionnaire approach. Questions like during this event or while using X, the automated vehicle in that regard. For example, I was free to do the things my own way would be a question for autonomy, or that I was successfully completing difficult tasks and projects would refer to the competence dimension, for example. So we have also shown in previous work that when we talk about automated cars, that it's mainly these four sub-dimensions, the needs for autonomy, competence, stimulation, and security safety, that are the most relevant for automated vehicle research. And we will also see this again on the results of our studies. So let's jump right into these two experiments. So the first one is called driving hotspots, cooperative interfaces to maintain a high user experience in SA level 5 driving. So when we think of full automation, and what could this mean for user experience, we know from previous studies that, users lament that there would be a loss of control, that these needs are not satisfied, that it's just boring to sit in this car and being transported. And on the other hand, many people think that manual driving is a very satisfying activity. So imagine you would sit in this beautiful flashy car, you would drive through the Autobahn, and you would have a lot of these potentially positive emotions. So the question is, can we somehow build user interfaces that would, at one hand, maintain the positive aspects of automation, potentially safety, for example, in the highway context, but still allow users to feel these positive emotions of manual control? And what we did is we went to a gas station at the German highway, and we asked people that were there to fill out this need scale and tell us a little bit about what they think is satisfying in highway driving. And what they, for example, said is, in the end, it would just have confirmed our expectations. For example, that using the steering wheel, that's not very pleasurable in highway driving because highways are mostly straight and everything you would do is just, keep the steering wheel in the same position most of the time. What is really funny in highway driving is accelerating or braking, so controlling the speed. And in highways, we have comparably high speeds, so this can potentially be a lot of fun. So we tried to integrate all that into a new interface that we call the hotspots interface that would share a cooperative control. So this means that the car would drive fully automated, just as any fully automated car, but drivers would at any time have the possibility to control the speed of the car, to hit into the gas pedal, feel the acceleration, or they could brake, or they would also like to overtake other vehicles. In that situation, we chose to use the indicator for overtaking. You'll see it just in a sec in a video. And we thought that, yeah, we were restricted by the restrictions of our driving simulator. Of course, you could go down that path even way further. For example, you could imagine that it would really feel a strong car could feel much better even accelerating with these heavy metal controls that you would find them on an airplane, for example. That could be a very interesting interface to control the speed. However, we didn't have that possibility, so we were restricted to the classical controls. So we did this study with the three different ways of driving, so to say: classical manual driving, and also automated driving. And yeah, we could again show also in our second study that that was comparatively boring for participants, although that's not participants, that's just me, 5 years younger, to enact for that video. And here we have a few sections of this Hudson-Blows interface. So optional overtaking, accelerating and braking. So what did we find out with that study? First of all, you see that the dashed line, that is the orange highway driving profile that we had observed when we did this small pilot study at the real highway with people out there. And that aligns very well with the manual driving data that we obtained in our driving simulator. What we can also see is in blue that the fully automated driving is really not very good in satisfying the needs for autonomy and competence, for example. However, the cooperative interface that we built could keep up with these downsides. So the green line shows it has nearly as good profile as the manual driving, so it can all maintain all these positive aspects of the user experience, while at the same time, with our interface, participants could not steer, for example. So there would definitely be an argument that there is some safety benefits involved, because a lot of what happened was still controlled by the automated system on board. So this need-based approach is a very promising direction to design interfaces that would maintain these different needs. So let's go. So summarize, yeah, the shared control interface could better satisfy psychological needs while maintaining the benefits of automation. To not run out of time, I will quickly go to the second study. Here we use the UX card to investigate SIA level 3 driving. We know there have been thousands of takeover studies in the last couple of years. A Google search brought me 260,000 results. So I'm not sure if it's really been that many studies, but there was a lot. And some have argued we don't need any more takeover studies at all. They have characteristics of a self-sustaining convenience. However, most of these findings were just obtained in driving simulators, so there are not many real-world tests out there, and especially user experience is not really addressed in most takeover studies. So most of them address safety, trust, or workload, or acceptance, but not a detailed investigation of user experience. And this is what we wanted to do. We asked ourselves, how would the dual task nature of level 3 driving influence users' experiences, so to say, switching between the driving and the non-driving related task multiple times? And how could in-vehicle interfaces support positive user experiences in that situation? I've shown this video already many times, so we'll just quickly explain it. We mounted a driving robot in a car, and participants were driving on a test track, and they had to interact with a smartphone or an auditory display to perform different tasks. It was either a visual non-driving related task or an auditory non-driving related task. And at the end, they had to do a takeover and control the vehicle into the free lane. And we used the XCAD methods already before the experiments and after the experiments, and asked with our participants in interview, what psychological needs do they think are important in level 3 driving? And after the experiment, would they think that these psychological needs have been fulfilled by this product and experience that they just had? We had 22 participants, 12 male, a female, 10 male, yeah, all university students, around 23 years old. Well, this is the result. So I showed you, I told you in the beginning, I will show you which are the important needs in automated driving. And this was confirmed by our participants already before the experiment. So when we asked them what will be the most relevant needs in automated driving, they clearly opted for security, safety, autonomy, competence, and stimulation, while meaning, popularity, and relationship are not that important. So when asked what they would expect from this automated level 3 car, they said, yeah, safety will definitely be a plus point because many people can't drive safe enough. However, there was also doubts about safety, like maybe when there is a takeover request, it could become disturbing. What if someone is asleep or distracted? And we had similar statements, of course, also for autonomy, competence, and stimulation, but I don't have too much time to dig into that deeper. You can watch the presentation video in the paper as it's part of this year's IV anyway. And afterwards, we could also see that, yeah, there were some interesting facts. So for example, for all our participants, the psychological need for security and safety was fully satisfied during the experiment. We had no participants saying that safety would have not been fulfilled, and we even had a participant who crashed into the obstacle. So even in that situation, these participants later on said, yeah, it was my mistake, but the system itself was very safe. Regarding the other needs for autonomy, competence, and stimulation, what we found out is that there are very differing reasons why people think something would be fulfilled or not. So, for example, some people were saying that they felt very competent because they've done all the work very well. Others said, no, I did not feel really effective because a takeover could happen anytime. So participants had very different reason for or against these particular needs satisfied. However, we also found out some interesting things. So first of all, there are high expectations towards level 3 driving. As said, safety is fulfilled for the most. But still, many participants, even in level 3, and we explained to them in the beginning of the experiment very clear what level 3 driving would mean, they still considered the driving task as a primary task in most situations. And those who did not felt interrupted by the takeovers. So what we could see is that, for example, most participants also preferred the auditory modality over the smartphone, even though the definition would allow them to use the smartphone. So the participants themselves stated that situation awareness is very important in level 3 drivings, and we need to make sure in the future that interfaces for non-driving related tasks would satisfy these needs in a way that this also grants for a high user experience of future drivers and passengers. So to quickly summarize, the need-based assessment of these automated driving functions allows to get rich insights into user perceptions, and these can help to develop novel interfaces and break with previous assumptions. So for example, with SIA level 3, we might need to rethink ICE-free driving. Even level 3 systems may support non-driving related tasks that support maintaining situation awareness. And the mere possibilities of the tour that occur anytime already degrades a user's experience. Or for SIE level 5 driving, we could rethink the automate everything mantra that we as technical people sometimes have. So even level 5 systems should provide different control interfaces that try to maintain a positive experience while driving. And I also was a little bit longer, but I'm done now and I'm looking forward to your questions.
Yes. So any questions from on-site or online?
Yeah, so many contents. I think, yeah, I need some time to digest. But I've got a question about the match things because I've seen you mentioned about the subjective evaluation methods of the UX experience. For example, the need scale, the UX cards, and to collect the subjective data. But at the same time, for example, on the field study or the driving simulation study, we will also get some objective data. But I'm not, these two data match together. For example, we give the information to the participants, and they need this information. And at the same time, maybe the efficiency is better than without the information. If it's match each other, it's perfect. But if these two information, if the subjective data and objective data doesn't match each other, how should we deal with this situation? Am I clear?
Yeah, absolutely. Thank you. I think this is a great question, because we have seen that often in driving simulator studies, that when we look at the objective data, people performing, for example, how long, what were their response times in takeover, and compared that with their subjective perspective, we often saw differences. So I even had this slide in one of my presentation where, as a result of that experiment, a human factor person would give different suggestions for the design of the car than a user experience experts who would lay more weight on the other kinds of results. So I mean, we are in a safety critical context, so safety should always be on top. But beyond that, we can always take the subjective nature into account. We also want to say that in these studies, we always assume perfect automation. Of course, if this automation is not perfect in real life, then we have additional problems. But in these studies, we looked, of course, way into the future. So with the level 5 experiment, we just assumed that cars will be good enough to maintain everything, driving performance on a highway, and participants would only intervene because of fun and never because of safety reasons.
Yeah, thanks so much. Thank you. It makes sense. Yeah, please.
Can I, Takahiro Wada from NICE. Thank you very much for your interesting talk. So I have a question on your first topic. I think it's a little bit related to the last question. So in your first part of the research, you mentioned that the importance of introducing the shared control or something to increase the drivers or passengers experience, right? So, but you connected the shared control with level 5. So, but it's very similar to the normal level 2 or something. So why do we need to have level 5?
So, I mean, we saw it the following way, that when we did the study back then, there was this tendency in the community that we just need more and more and more automation. And when the automation is good enough, we can just remove the steering wheel from a car, right? But we said maybe that's not what we should do because we want to have communities that use these cars, even if they would like individual driving, so to say, if they would want to own a car. So and our idea was, just because the technology would be able to do level 5 driving does not necessarily mean that we have to restrict people from contributing to the driving task. But in that sense, it's true. It's not a class. We often have the assumption that level 5 would mean, okay, no controls mooring in the car, but this is not necessarily, doesn't have to be that way, right? So we can still have a level 5 car that would, by definition, be able to travel anywhere in all situations. But at the same time, we could still override that automation and contribute to the driving manually, if we like. That was our idea behind the project.
So I want to ask from the different direction. So I mean, I think it's just a kind of the switching strategy from level 5 to level 2. What is the difference between this kind of thing and your project?
If you want to frame it that way, maybe then there wouldn't be even that difference. So the only difference that would be there is that there would never a need to switch to level 2. It's solely on the driver's fun part to activate the manual function or not. The car would never say, please drive.
Gradual change, gradual transition between these levels.
Yeah.
I understand. Okay. Thanks.